And now I will explain question 8 from tutorial 12. Right, so here we have a differential equation. So notice that it is a linear, non-homogeneous, with non-constant coefficients. Right, so the coefficient at y double prime is x squared. The coefficient at y prime is 3x. So coefficients are non-constant. Okay, part A. In part A, we are supposed that y1 is a solution of the associated homogeneous differential equation, right? So it means the following. So it means that if we copy this differential equation, so x squared y double prime plus 3x y prime plus y, and substitute y1 as y into this equation, then we're going to get 0. So this is what the word homogeneous equation means. Right. So now we are going to look for a general solution of the non-homogeneous differential equation in this form. It is something like variation of parameters. It is kind of similar to variation of parameters, but not quite the same thing. All right, so we are going to look for a solution of the original differential equation, the non-homogeneous one, in the form some function of x times multiplied by some solution of the homogeneous differential equation. So I guess the idea here is that if we somehow can guess what the solution of at least one solution of the homogeneous equation, then we can figure out what the general solution of the non-homogeneous equation is going to be, right? So, and in part A, we're supposed to show that we have this differential equation, that c of x satisfies and its own differential equation. Okay, so let's do that. So again, as I said, my y is c of x times y1, right? So my y prime is going to be, now I've got to differentiate this according to the product rule. So it's the product of two functions of x. C is a function of x, and y1 is also a function of x. So it's going to be c prime y1 plus c times y1 prime. And we have our second derivative, so we've got to find the second derivative too, so it's y double prime. So I've got to differentiate this according to the product rule, and it's going to be c double prime y1 plus c prime y1 prime. So this term is done. Plus, now I'm going to do this term, the second one, c prime y1 prime plus c times y1 double prime. Now the second term is done, and I can also combine these two together, right? So I guess I'll just write the number 2 here. Okay, so this is y double prime. Okay, so now I'm going to just substitute it, plug it in back into the original equation. So this is y, this is y prime, and this is y double prime. Okay, so doing that, I will get x squared times y double prime is c double prime y1 plus 2c prime y1 prime plus cy1 double prime plus 3x y prime is c prime y1 plus c y1 prime plus y, and y is just c y1, and this should be equal to 4 ln x. All right, so on the other hand, this ln thing is, let me just recombine them together. So I'm going to combine all the terms with c double prime together, all the terms with c prime together, and everything with just c together. Okay, so first, let me write, combine all the terms with c. So we have c here, and c here, right? So c times, I'm going to have x squared times y1 double prime plus the second term is going to be cy1 prime plus, sorry, I already have my c, so it's going to be 3x plus the third term is just y1. Okay, so plus c prime. So what is the coefficient in front of c prime? So I'm going to have from here I'm going to have 2x squared y1 prime plus where else do I have c prime, and again I have c prime here, so plus 3x y1. All right, and I will also have c double prime, so plus c double prime times x squared y1. Right, but notice that this whole thing is just 0, right? So because we assumed y1 to be a solution of the homogeneous differential equation, which literally means that this is 0. Okay, so I can delete this. But then whatever remains is precisely what I'm supposed to prove, right? So let me just use similar colors. Like this term is here, this term is here, and this one is here. All right, done.